Hello and welcome back to Guillotined Chemistry. Today I'd just like to take a brief look at the hypothesis, and it's a tricky term. We've all learned definitions of the hypothesis, and we've pretty much memorized them, regurgitated them, and never thought much about them. But if you really think about the definitions that we've been taught, that they're educated guesses, that they're if-then statements, it's almost like, why do we even have a hypothesis anymore? And so let's look at some common misconceptions about the hypothesis and see if we can't clear these up. Now, again, I wouldn't get into a bar fight over this stuff, but we have the term, and we really should try to differentiate it and see what use it is to the scientist. And so the first misconception a lot of people have is that a hypothesis should be an if-then statement. We've all learned that, but the if-then statement doesn't really do the hypothesis justice, nor the prediction. Really, you want to start thinking about the hypothesis as the if of the if-then statement and your predictions as the then. So a good hypothesis might have a lot of thens. Then you could predict A, B, C, D, E off your testable answer, your hypothesis. So keep that in mind going forward. The if is the hypothesis and the then would be your predictions. A lot of people also tend to say that a hypothesis will end up explaining something. It's like a baby theory. But we really don't want to look at a hypothesis as something that would attempt to explain something, because that's going to really limit what we can do with these. What we're going to find out is that there are things that are subjective and objective. There are inferences and observations. And if a hypothesis only tries to explain, then that means they're inferences, and that means they're subjective. And if that's the case, then we don't really have anything like a hypothesis to serve something that would be more objective, more observational. And that's why we got to make sure that it's open to both the inference and the observation, the subjective and the objective. And then finally, I touched on it just a couple minutes ago, and that's the idea that a good hypothesis could eventually, with enough data, become a theory or a law. And again, I always thought this too, but now that I've started to research it, if that's the case, then we don't need hypothesis because it could just, we just have untested theories and theories without a lot of data or evidence. Really, the way we want to look at this is that the hypothesis is a narrow phenomenon. It's a narrow set of things that you're studying, and it's never supposed to get bigger than that. If you're trying to cover a wide range of phenomenon, if you're trying to get something to cover an umbrella of stuff, then that's going to be a theory or a law, not a hypothesis, whether or not it's been tested or not. And so we'll talk a little bit more about theories and laws later, but I thought it would be nice to come up with a hypothesis, a prediction, a theory, and a law for just something really simple like stepping on a juice box. And so a hypothesis might be that stepping on a juice box will increase its pressure. And so if that's the case, if your prediction is that the pressure is going to build, then your prediction might be if the pressure builds, then the juice box will explode. So that's the if, the hypothesis, and then the prediction, the juice box will explode. And so just to tease the next video, we can come up with a theory and a law just to show you how much broader those are versus a hypothesis. And so a theory of this might be that the explanation of what's going on is that the gas molecules are bouncing around, and when they collide with the containers, they exert a pressure, a force. And so that's a pretty broad idea, and that's actually kinetic molecular theory. That's the way we look at all gases. And a law might be, all other things being equal, if we were to measure these things, that there would be an inverse relationship between pressure and volume. As pressure went up, volume went down, or as volume goes down, pressure goes up. And that's an actual law called Boyle's law. And so notice that the theory tries to explain, and the law is more of an observational statement about a wide range of phenomenon, which we'll talk about more in the next video on theories and laws. So hope that didn't hurt your brain too much. Again, mull this over and let me know what you think. Am I going too deep in the weeds here? Let me know. Thanks for watching, and have a great day.